Assalamu alaikum viewers, this is Sania Khalid and today I am going to discuss about one of the most important topic in the analysis of algorithm, that is Strassens algorithm. Strassens algorithm is basically what? It is a method to solve the matrix multiplication in the most improved way. Like it uses the technology of the divide and conquer method to solve the matrices faster. Like no doubt we have many other ways to multiply a matrices by simply multiplying their each row with each column, and but the Strassens algorithm is used to multiply the matrices that have size greater than the 2. For example, like we have a matrices for 3 by 3 and 4 by 4. To multiply such type of matrices, we use the Strassens algorithm that helps us a lot. The standard matrices multiplication take the times big O of n cube, while the Strassens algorithm reduces it to big O of n raised to power 2.81 something. No doubts the difference is very small, but it's make our algorithm much faster and efficient to work. Let's understand it through our nodes. So there is, and let us start our discussion. In normal multiplication of size 2 by 2, we have to like matrices of size 2 by 2 like A and B, and for this purpose we have to multiply the each row of A matrix with the each column of B matrix. So we will get the matrix C, that is the product of the A and B. Here we have some formulas like C11 and C12, C21, C22. It is basically C11 is basically find out when we multiplied the first row of the A with the first column of the B, and so on, C12 and C21 and C22. This is fine, but it is unable to solve the problems for the matrices like 3 by 3 and 4 by 4. The time complexity of the Strassens algorithm is when we have n is basically the number of size of matrix. When the size is less than 2, then it is a constant value, but when the size is greater than 2, then if we use the Strassens algorithm, and its time complexity will obviously become 70n by 2 plus n square, where 7 is the number of multiplication that helps in the Strassens algorithm. So, our next topic is master theorem. Master theorem is what? Master theorem is basically used to solve the recurrence relation. Like, it is used to find the time complexity of the problems that involve both the recurrence part and the non-recursive part. So, its formula is basically Tn is equals to A T n by B plus f of n, where A T n by B is the recursive part and f of n is the non-recursive part. So here A is the number of the subproblems. Like in master theorem, we use the divide and conquer method, and we divide a big problem into different subproblems. So A is the number of problem in which we have divided our problem, and the B is basically the factor by which we divided our problem. And the A should be greater than or equal to 1, but the B should always be greater than the 1. So here are some rules for the master theorem. That is that is help us to find out the time complexity of the problems. So the first one is the log B of A is greater than, what if log B of A is greater than the K, where K is the power of the non-recursive part. Here A and B is the same as previous, as in the formula, like A is the number of subproblems and B is the factor by which we divided our problem. What if our log B of A is greater than the K, then our time complexity will become O big O of n raised to power log of BA. Like the greater one part become the power of the big O. In the same way, the second case, as in the formula, like A is the number of subproblems and B is the factor by which we divided our problem. What if our log B of A is greater than the K, then our time complexity will become O big O of n raised to power log of BA. Like the greater one part become the power of the big O. In the same way, the second case, if log B of A is less than the K, then the time complexity will become n big O of nk, where k is the power. And the last and the third rule is that if both become equal. What if the recursive and non-recursive path have same complexity? So what should we do in this case? In this case, we have considered the both as complexity. So time complexity will be t of n is equals to big O of n raised to power k log b of a. As k is equals to log b of a, so either you can replace k with log of ba, or log of ba is equals to k, right? So final time complexity will become t of n equals to big O of n raised to power log b of a dot log n, right? And that's all. And now we have the conclusion. Conclusion basically involve Strassens algorithm is one of the fastest way to multiply the matrix that have size greater than 2, and the Strassens help us a lot in matrix multiplication by reducing the time complexity from 8 to 7, improving the time complexity from big O of n cubed to approximately big O of n raised to power 2.81 using our dynamic and divide and conquer approach. So the next is the master theorem. In master theorem, we have master theorem as provide an efficient way to analyze the problem to find their time complexity that consists of the both recursive and non-recursive part. So it helps us to find the time complexity without solving the recurrence stuff, and it would become easy for all of us to find the time complexity of any problem using the master theorem's formula. So that's all. Thank you so much for watching this video.